I mean, the logging, you're talking like 1 hertz maximum is your usual logging rate, which, I mean, in a car, in anything, it was just
not too useful in most motorsport applications.
Yeah, he'd be like, I wonder what happened in this massive gulf between A and B. We've no idea, we just got to guess.
Yeah, right.
But in like sailing, you're going around like 5-6 knots.
Yeah.
Not really much happens in 1 second.
No. All right, on the podcast today, we've got Peter Knight from Emirates Team New Zealand. So a bit of a departure from our usual motorsport themed podcasts, but of course America's Cup, particularly in current guys, there's a lot of electronics goes into that. So Pete, you're an electronics engineer with Emirates Team New Zealand, fresh off a win defending the America's Cup. Must be pretty happy with that. Can you start by maybe giving us a bit of a background on how you got into electronics engineering and sort of came to be on the Emirates Team New Zealand team?
Yeah, it shouldn't be too long. My background is in sailing. I came out of university in the UK and went into sailing, professional sailing. Then joined a company in the UK called Diverse Yacht Systems as an apprentice, and we did kind of logging side of hardware for boats, and did that for about 10 years, half working, half sailing. Towards the end it was all sailing pretty much. Then a chap, 2017 when the Cup was in Bermuda, a chap, Chris Draper, who's done a good job getting a lot of POMs into the America's Cup, sent me a message on Facebook and said, we're looking for some more people at Team Japan. Do you want to come to Bermuda and try out? So I went over there and did the last 6 months with Team Japan.
Okay.
And once I was in, I was in. And after that, did a stint with SailGP, and then 2 years ago now, put the feelers out to Team New Zealand, and they were in a good spot. They had a bit of a gap in personnel, so I came down, tried out, and joined the team there.
Can we just go back a little bit? So when you were going through university, what was your actual degree?
I did international relations
so
at university, which
not specifically related to electronics engineering.
No, I actually regret I didn't do engineering at uni, but I didn't know what I was doing then.
Sure.
And in sailing, you can go quite a long way just sailing, but you don't earn a lot of money. So I needed a dual job, and electronics was what I ended up doing.
And where did that knowledge come from? I mean, obviously, a lot of people in that industry will come from a degree background. You haven't. So was that sort of self-taught or in-job training?
In-job training and self-taught. There's no structured career path you might go through with qualifications. It's all on the job.
Sure.
And there were some great men at Diverse Yachts who I worked with who got me to a stage where I could branch out and get on the bottom ladder of the America's Cup game.
Now, I know we're going to get into talking about these really impressive, complicated America's Cup yachts, but you mentioned there talking about logging and maybe a sort of lower level of sailing. So what does logging or data in general mean, or electronic systems mean for a small yacht?
Yeah.
I think on face value, you might consider that there's not a lot of technology really applied in terms of electronics and logging on yachts. Obviously, the America's Cup, we're sort of familiar with a bit more, but yeah, the lower level, I am interested. Had the same question on my mind.
That is a good point. In marine electronics, really, the America's Cup is a bit out there, over the top. There's mechatronics, really, but what I did, well, most people's yachts, if you own a boat, any boat really, you'll have a depth sounder and a heading source, speed, wind, and teams spend a huge amount of money trying to get an accurate, essentially boat speed, position, and wind measurement, which is harder than it sounds actually, and then logging that data for post-processing in a Grand Prix team. But that's kind of filtering down now. You might see pretty much any team looking at their data, but
how are those teams using that data and post-processing to, are they using it to try and improve the boat, or are they using it on tactics or sailing techniques, or is it just a combination of all of the above?
How how to keep this in the scope for now is quite difficult, but essentially you might use it to validate changes for sail trim. Actually, when you're going, might be tactics, might be strategy. Also, a very big thing when you're looking at tactics and strategies. There's a lot of software use now, which is based on, the fastest way from A to B, and to do that, you're inputting weather data. You also need to know pretty much how fast you're going to go in each direction, in each wind strength, and to come out with that data, which we call polars. You do a lot of data analysis because I imagine in cars you put your foot down in a direction, you go a certain speed, but in sailing, different wind speed, different sail combinations, you go a different speed at a different angle in a different direction. And if you want to use software to calculate the fastest A to B, you need a really good array of data about your speeds that you'll do from A to B, and that's one of the key points of the data analysis.
So, I mean, there's obviously a lot of correlation between, particularly America's Cup with the technology, and motorsport, which is the industry we come from. And I mean, on a racetrack, it's pretty simple. The racetrack really, within reason, is always going to be the same lap after lap. Yes, there are differences with rubber build-up, etc. But basically, it's the same, and your engine makes the same amount of power. Again,
going in the same
reason.
Direction.
You're
going to go on the same track.
Yeah. But I mean, from one leg to the next in yacht racing, I mean, the weather conditions are constantly changing, so your power source is going to be different leg after leg. The conditions of the water as well are constantly varying. So, I mean, can you bring all of that information in real time and actually give the helmsman information on what the best course of action is, or is that sort of in real time not practical? And I guess following on from that question, does that really take the skill of the helmsman and the team out of it and just make it a robot competition?
That is a good question, and I think it's very similar in car use to boat use, that in the end we can feed back really accurate data and pretty much the direction to go. You could have a target rudder angle, direction, speed, even to a certain extent sail trim, but still the best guys are the guys who started sailing without any of this and have come on up.
Got that inherent sort of understanding of what to do.
Yeah. And actually, I was talking about this the other day. Pete Burling, a really good guy, come from dinghy sailing, exceptionally good sailor, and we do data analysis, blah, blah, blah. But also, a huge amount of the feedback is actually personal analysis. He's feeding back how he feels about things.
Sure.
And I get the impression in the car world, probably until very recently, all the feedback was from the driver about how the car's feeling rather than the telemetry.
Well, Tim comes from a race engineering background, so you're probably pretty in a good position to speak to that.
Yeah, I mean, certainly if we talk about within the last 30 years, that's probably when, data, like log data, objective data has probably become more, heavily integrated. Before that, the technology just wasn't really there to practically carry around, heavy stuff that logs data in a car.
Yeah.
But these days, certainly within the last 20 years, I would say objective data has become pretty heavily integrated. But yeah, there's definitely a lot of crossover there. What about some of the sensors that you guys are actually using on, let's start with maybe some of those slightly simpler boats before we get to these big Flash America's Cup boats? What are they actually using for things like speed and direction, and what sort of sensors and stuff they actually got fitted to the boats? There aren't actually that many sensors we would use on a traditional boat. It would be a speed sensor, which most of the time would be just a paddle wheel in the water measuring. So it's physically like the water with respect to the boat.
Yeah.
Does that get a little complex as opposed to using maybe something like GPS, because then obviously it's also going to be influenced by any current in the water. If there is actually water flow, obviously you're not always going through water that's stagnant, I guess is the term.
This is the hardest part, is that you can measure a car speed with GPS or presumably wheel speed is pretty fixed. You're always going to have a very good idea how fast you're going. But in the sea, because you're on a moving carpet, which is the water, and you could just use GPS. But if your whole carpet's moving, if your whole platform's moving, then you're not actually getting an accurate boat speed, and you might be faster going this tack than that tack, depending on those conditions. And actually getting a really good boat speed calibration, because the flow direction's different with your heel angle, like your angle of attack on this measurement device, is the hardest thing, is to get your boat speed, essentially.
Sure.
Because there's actually 3 speeds going on there, right? Like there's the speed with respect to the earth, there's the speed with respect to the water, and with respect to the air as well.
Yeah.
The atmosphere. So it's actually a huge number of variables straight away.
And without getting too technical, but the boats I work on, the boats most people own and sail, you would go around at like 8 knots, 10 miles an hour. And at that point, your vectors are pretty small. I mean, 10 miles an hour or 9 miles an hour is not that big. What am I trying to say? Essentially, all your measurement differences are quite heightened because you're going so slow that if you've got 1 knot of current and you're going 6 knots, to use a different unit, then that 1 knot is massive. But if you've got 1 knot of current and you're going 50 knots, it's a lot smaller.
As a percentage, it's less relevant.
So we don't worry so much now about actually measuring your speed through the water, because you'd say, I use the GPS because it's a 2% error rather than a 20% error.
And what about measuring relative wind speed and stuff? Is this like pitot tubes and stuff on manometers?
Pitot tubes haven't become a thing, and the reason for that I don't know. It's not something I've got a lot of experience with, but potentially because a lot of the speeds we're measuring are so low. You know, a 30 knot day would be a windy day.
Yeah.
And you're trying to measure the difference between 8 and 9 knots of wind speed. So it's more like quite simply like counters with a mechanical cup.
Yeah.
Different companies make these, like a wind vane,
a
weather station.
Yeah.
You can spend a lot of money on those, but in the end it's a counter and a direction.
Got you.
So actually relatively simplistic.
Relatively simplistic, yeah.
Okay.
But there's a lot more back-end work where you've taken your measured speed and angle and your boat speed, and then you're trying to work out where actually the wind's coming from, not just where your apparent wind, but where your actual wind is coming from. And that's the back-end hardware. That's what you're paying for when you buy a B&G system.
So when you're sort of talking about trying to build up a bit of a map of what's around you, like where you might want to go and what's going to happen if you go in certain directions, but how are you doing that? Like you've only got a certain amount of sensors on the boat, so how are you kind of looking out and working? Is this coming from other sources, from external from the boat, or?
If you were doing a long race, if it's a short race, you might be looking at forecast.
Right.
Or if you're doing a local race, you might have local weather stations. Offshore, you'd have data, you'd have grid files. But generally, you look up the track. Well, the best guys are just looking up the track.
Right. See
what's up there, what's the wind doing, what are the other boats doing.
So then again, just the data really less relevant, and that's more an experience thing.
Yeah.
So this is even looking at the surface of the water.
Exactly, yeah.
Right, okay.
Yeah, the best sailors are the best sailors. In the end.
The electronics will only help so much.
Yeah, for sure.
Yeah. So in terms of the systems you're using, is this bespoke logging equipment that is made for sailing, yacht racing, or are you adapting motorsport-based logging hardware and software?
At the low level, there's companies that sell marine specific. There's a couple of big companies, Ray Marine, B&G, and they make their own gear for this kind of thing. But no idea, we just got to guess.
Yeah, right.
But in like sailing, you're going around 5-6 knots.
Yeah.
Not really much happens in 1 second.
No.
And you've got to go up the chain before you would end up with a motorsport style logging system.
Well, let's move forward a little bit more to our main topic, which is the America's Cup. And I've followed that loosely over the years. Obviously, New Zealand, I'd like to say, punches well above its weight for the size of our country and our funding. So pretty stoked that we're able to defend the Cup again. And in terms of the regulations for it, and they're spectacular to watch, but getting a little bit away from what we sort of think of with traditional yachts with the foiling monohulls. For a start, could you maybe just talk us through the hardware and electronics that are kind of so essential now to a foiling monohull and making them work?
Yeah, I guess if you compare it to the old days where, sails attached to ropes, attached to winches, that might have had a mechanical drivetrain with someone turning some handles. Now, for efficiency reasons of power transfer, almost everything's hydraulic, except the winch we have, which is actually in the rules. Otherwise, probably wouldn't have a winch. Hydraulic control is a much more efficient way to move power around the boat. And within the rules also, there's certain things like either the arms up and down or the flap actuation on the arms, which is driven by a hydraulic motor. So, well, you wouldn't have to have a hydraulic motor, I guess, but essentially it's a much more efficient way to transfer power on the boat. Sure. So unlike the old days where it's human mechanical power, now hydraulics has become the way. And that's meant you need to control the hydraulics, which different teams use different platforms for doing that, and that's getting into the autosport territory. Companies like Cosworth, Motec, and my last job we used the Motec PDM modules for the high power stuff, and that's where this integration, moving from just being a kind of data instrumentation man, then you jump up and you're thinking about actuation of stuff. So
you've now got some control in there, as opposed to just the data logging side of things. So just to come back, for those who maybe aren't familiar, you've got the hydraulic systems, but that's still a function of humans. You've got the grinders who are there to actually produce that hydraulic pressure, which then can be used for whatever functions the team require.
Yeah, it's changed for this one. In Bermuda, every hydraulic action had to be powered by human power. So you'd see the dudes grinding away, or in the Kiwis' case, cycling away, driving rotary hydraulic pumps, which would be filling your accumulator, moving stuff. But these boats needed a lot more power, especially to raise the arms. So they decided, we'll allow hydraulic pumps, were driven battery powered.
Oh, okay, right.
Pumps to do the hard yards for those pieces, and they separated it out. So you've got your rake controls, your flaps, and your rudder rake done by a motor powered. But all the sail controls are done by humans.
Okay, so that's why we've still.
So they're still grinding away to do all the sail controls.
Could we just talk through how these boats actually work from a really high level? Like when most people think of a boat, it's floating in the water. It gets pushed along by the wind in some way on a sail. These boats are pretty extreme and a little bit different to that. So could you just talk through maybe some of how they work and maybe some of the main components you're using to control them, like with rudders and foils and stuff like this?
Yeah, this is quite a complex question, but
just give us the 30,000 foot view, maybe.
Yeah, all right. So if we were to break it into, I guess, 3 areas, which is quite handy because that's how we break down the control loops. We've got the arms, go up and down, and you're always foiling on one arm. It's got your arm, you've got your horizontal at the bottom, it's like an aeroplane wing. And there's a separate control system to move these arms up and down, which is one design part throughout the teams.
So it's a common part.
Common part,
okay,
yeah.
Right.
What do you call it in motorsport?
Controlled.
Or
homologated
part.
Means you don't have to worry about it.
Yeah, so that you've got this homologated part, which is the FCS system, which raises these arms. And then also the arms are one design part. Then the boat actually flies on the horizontals on the bottom of those arms, which are flaps, 2 flaps each side, inboard, outboard. And they can be controlled within some scope any way you want. You could have, I mean, they could be electric, they could be hydraulic. You could have 4 rams down there, you could have 2, you could have whatever. I can't say what we had, but different teams had very different approaches to this. And that closed loop system you can power with stored energy, like a battery driving a hydraulic pump. You could have it electric driving those, whatever. And then, so that's giving you lift at the front. At the back, you've got a rudder with a lifting piece on it. And that there's no flap there. You just move the whole rake of the rudder back and forwards to change your angle of attack.
So by adjusting the two, you can control the attitude of the boat.
Yeah,
I was going to say in the water, but of course it's flying.
So it is actually really similar to a plane in a lot of ways. Like it's not like this hull is designed to be in the water. It's quite literally flying on a large wing somewhere near the center of gravity, I guess, and then you're trimming it really with this rudder at the back.
Yeah, yes, essentially yes. It would be a lot like turning your Formula One car upside down.
Yeah,
and then you're kind of balancing on your front wing and rear wing.
I mean, just to bring it back to real simple terms as well as to why you're doing this, for those who maybe haven't followed America's Cup, it's all about reducing that drag through the water, which we've got a conventional mono hull that's in the water, huge amount of surface area contacting the water, and that ultimately limits the drag on that, limits the speed the boat can go.
Yeah, exactly so.
Just in terms of some numbers as well, I know for me, I find it incredibly impressive. Could you give us sort of, I don't even know if you've got data from, sort of typical speeds that the older America's Cup non-foiling yachts were capable of versus what we were seeing. Obviously, we never really saw the ultimate wind conditions that Team New Zealand was built for, which is a real shame. But what speeds were we seeing? And sort of in terms of like what speed the boat can achieve versus the wind speed, because for me, that blows my mind.
Oh, yeah. So back in the day when the last time the Cup was here, I guess with the version 5 boats or before, at a push on down a wave, they might get 12 knots, which I don't know is 15 miles an hour or something like that. It's not, it's almost 15 miles an hour. And that would be like full gas down a wave. It would start to strain everything. And I think in the light breeze, you might go 1-to-1. You might go upwind 8 knots and 8 knots of breeze. They're really efficient, but really efficient at low speed. And now, I mean, everything on the news is about how we're going 3 times wind speed. So the top end of all the boats is around 50 knots. I don't know what that is in miles per hour. It's fast.
Yeah.
Yeah, I mean, you're getting up to around 100 kph.
Yeah.
And you might, on a bearaway, do that in 12, 14 knots. I mean,
that's
so
pretty
it's really an enormous step compared to a conventional boat, what most people would think of as a boat.
Yeah.
Could you talk through basically this, in simple terms, what the physics are that allow you to sail faster than the wind? What's actually going on there?
You're taxing my my knowledge of yacht design here, but essentially
electronics engineer, not aerodynamicist.
Well, no, it's not so difficult in that as soon as you start sailing faster than the wind, you've got more of it. Like you're generating your own apparent wind, like you.
Because the main sail is essentially much more like a wing than it's not like a sail that's at 90 degrees to the wind here that's pushing this thing along. It's really got its own camber, and it's actually it's a lifting surface, right? Yeah,
there's flow over all the sails. No, not like the old days where you put a flat surface and the wind came and hit it perpendicular. Now it's at every stage it's flow going over the sails.
Yeah.
So I guess for me as well, how much of the gain in boat speed versus wind speed is due to the advances in the likes of the wings, the sails, just call them wings, versus the obviously the foiling is a big aspect of that. But is it purely the foiling, and the fact that the hull is out of the water, or is a lot of it come down to advances in the design of the sails as well?
Pretty much, if in one simple way, it's the foiling is reducing the wetted area and the drag. But as with everything in yacht design, like, you've got to have a high efficiency aero plan to meet the high efficiency hydro plan. Otherwise, if you took your average yacht that you just go and find in the harbour, started foiling on it, I mean, the sails, they wouldn't be able to stand up, they just flap. You wouldn't be able to continue to have flow over the sails. So high efficiency here, but the key is the reduction in drag.
Yeah, sure.
I mean, you imagine the drag of your yacht or the drag of our rudder foil would be like this table size would be almost nothing. It's nothing.
Yeah.
And the other thing to say was, because we're generating all of our righting moment by having the boat leaning out on an arm, unlike the old days where you'd have 18 tons of lead attached to the yacht, so you'd be dragging around 18 tons. Now there's none of that. I mean, the all up weight of the boat is way less than just the bulb on the old boat that's outside the base.
So physically, it's just a lot. You can accelerate this thing a lot faster just because it physically weighs a lot less.
Yeah.
Yeah.
Yeah. Reduce drag, increase the horsepower.
So in terms of the control, you've sort of mentioned some of those aspects that that the team have got at their fingertips, which to me, again, coming from a non-sailing background, sounds like a hell of a lot going on compared to in the old days. I guess you had your sail trim and you had your heading, and kind of, I'm guessing that was pretty much it. So now you've got all of these parameters. So first of all, is there any electronic control in there to help automate, the attitude of the boat in the water, or is that all got to be a function of human input?
Yeah, that is a good point. That also coincides with the rules of this one. That sure, the boat could be better. You could automate everything quite easily, 3D autopilot for ride height, but when they wrote the rule, they thought this is much better competition if it all has to be human skill based. So you can't have, say, an autopilot can't do the ride height. It's got to be a human with a twist grip on a wheel or somewhere. And he can't. In Bermuda, one of the big advantages for the New Zealand team was they had essentially an autopilot on a screen with a line, and this geezer would just follow this line up and down. So he was the human interface,
right,
bridging the gap. But with this one, in the rules, there has to be a 1 second delay between the instrumentation system and the display. So I guess they decided
take away some of that advantage,
that you couldn't have an autopilot system that would be accurate at 1 second ahead of real time.
Yeah, okay.
If you've got that 1 second display built into that feedback loop, does that mean that the person trimming the boat like that do they stop relying purely on that system? Are they also kind of looking out and using other ways as well?
Right. We don't. I think everyone really is using feel and sight rather than. Right. I mean, at that speed, with a 1 second delay, this data is no use to you.
You're covering a lot of ground.
You're covering a lot of ground. It's really fast, and everyone's looking out, looking at the foils. Yeah. It's all human action, human intuition. Mm-hmm. And I think the ride height controllers for all the boats were some of the most pressured guys. Blair and the drivers on the Italian boat. They had a nice setup, but yeah, they're pretty pressured guys to keep it all going.
So is the ride height, the hull height above water, quite a critical metric that you're trying to control for optimal performance?
Yes.
And how does that play in? I mean, we know that for like highly developed aerodynamics on race cars, the height above the ground is really critical to the aero performance, particularly for the underbody. But I don't know if I see that sort of same correlation with yachting.
It's actually exactly the same. And if you could have a system where you could have a moving skirt and seal yourself to the sea, that would be absolutely ideal. But essentially, if you obviously too high is too high, too low when you're in the water and it's dragging. But if you imagine the size of the mainsail, and you look at that, if you manage to get the boat so that the bottom of the boat is just touching the water, like within centimeters, then the size of your mainsail is actually from sea level to the top of the mast.
Oh, okay. So you haven't actually got the airflow underneath the hull.
You've got this whole high pressure section which is all the way down to the sea.
Okay.
Which is far more efficient than if you were another meter higher. You've got all this air going under the bottom.
Sure. Yeah.
Getting away.
Yep.
Yeah.
And I presume you've got water, you've got air, so you're trying to keep the foil, I guess, in a sweet spot as well, so it's not ever coming out of the water as well. If it gets too high,
too high,
it's going to stop lifting.
Yeah.
Right.
I mean, there's so much on that you're looking for this ideal ride height. At the same time, you're looking for minimum pitch on your foils. I mean, you don't want to have a massive angle of attack, and you're thinking this is somewhere where you do the simulation. You're like, oh, obviously this will be best.
Mm-hmm.
But when you actually come to it, it's very hard to maintain this little bit, and sometimes a bit high is better. Never a bit low is better, but the guys just out there all the time training so they can just get better at trying to get to this absolutely sweet spot with minimum pitch angle on the foils.
To be as efficient as possible.
Yeah.
Yeah, you just mentioned simulation, which again, obviously, there's a big part of modern motorsport, particularly is testing gets more and more expensive and more restricted. So, you're relying quite heavily on simulation for the development of the boat, and is this also something that the helmsman and the team are actually using to improve their performance?
Yes, I'm sure it's no secret that all the teams use simulators now, the same as Formula One. And they'll go in there day after day. I think it used to be quite rudimentary, but now certainly we've seen videos of the British guys and they've got a pretty sweet setup.
So we're actually talking about like a fake boat set up in a room where they're sailing this thing on a screen or something.
Yeah, I mean, on the one hand, you could be really simple where it's a TV screen with a steering wheel, and you could be the totally other end of the scale where you have VR goggles, hydraulically actuated boat that Artemis Technologies did, and all of that stuff. And then I mean, there's so much you can do. If you've got a good simulator, you can use it to design your input devices, because you test them out here. Oh, I don't actually like the way that feels. Okay, we'll make another one before you
make the actual part.
Yeah, and I mean, this was something that was a big difference for me in Bermuda, that while the Kiwis were doing their stuff here on the simulator, us old school yachters in Team Japan, if you wanted to test a part, you had to go sailing, and to go sailing is a massive job. It's not just pushing the boat off the dock,
no.
Wing step, and 50 people to get the boat sailing. You might sail for 3 hours on a good day. So to actually go through the development loop is
much more time
consuming. It's just
consuming.
such a major, compared to having a simulator where you test something. If you've got a good physics engine on your simulator, you can really test things before you put them on the boat and go.
Is that going, coming back to the likes of F1, they rely on, I think they call it driver in the loop. So the engineers will develop parts, or even down to suspension kinematics, and then load that into the simulator, and they'll have their driver go and run laps, and they can actually validate how that part or change related to lap time. You've been talking there about sort of some of the driver, sailor, helmsman inputs.
Yeah.
But did that go as far as sort of developing the foils, hull shape, etc. earlier on? Was that all sort of validated in a simulator, or do you sort of more rely just on CFD for that?
It certainly was. Yeah, I don't know where the limit was, but certainly to test some different foil shapes is a thing that we would have done. I'm sure everyone else did.
Mm.
And also, if your simulator's good enough, you can test the best angles for things, the best way to go through maneuvers. You can test everything. And it is driver in the loop. And I must say, you know, Pete Burling's an engineer by trade, and he is definitely in the loop for everything, pretty much.
So this is where you essentially got a mathematical model describing the physics of what it means when you've got a foil going at this angle versus this angle. We trim it in a different way, and it's kind of like the helmsman is using it, and there's a computer simulating what would be happening in real life, and you can actually load new parts into this thing and try them back to back.
It's just a big computer game.
Yeah.
In the end.
How many people? I mean, obviously there's quite a few people on the boat when you're sailing it. How many people would be involved in that simulation? Is it just the person steering the boat that's part of the simulation, or are there 2 or 3 people involved when you're actually on the simulator?
I couldn't say exactly because it wasn't my scene, but I've certainly seen with other groups, other teams where, but for Bermuda, Artemis had a whole side of the boat, so they'd have everyone in there.
Right.
Obviously, the grinders probably don't turn up for the simulator, but
Save their energy.
yeah, it could be anywhere from really small to, I would imagine, everyone.
Yeah. Okay.
You know, so it doesn't really answer your question.
I understand. I mean, it can be quite complicated. Like, I can see the advantage in making it as realistic as possible, for sure.
I'm sure you could. Sometimes you just want to go down there on your own. You can run it without everyone, and sometimes you want to go down there for a team effort, so everyone gets involved. So I guess there's more dynamics there than if you just have your car with your one driver. But yeah.
How many people are actually directly involved in controlling something about the boat? Obviously, the grinder's there to largely provide power.
Yeah.
How many people are actually doing something on the boat that controls its direction, its height, the way the wing works, all that stuff?
I never really thought about it. Well, obviously you've got a driver, you've got a ride height guy who was Blair, and then a sail trimmer. So 2 guys also helped out. So what's that? 1, 2, 3, 4, 5.
Yeah.
5. But also the other the grinders, although some of them were just in a grinding only role, some of the guys are involved with other controls, and even them. Actually, all of the grinders, you're always controlling your flow rate and stuff, so they're all involved in their own gearing and knowing when they're going to do things. Right. I guess everyone had a part to play, but there was a couple of roles where it was just head down, power out. But everyone else was involved.
Yeah. Now, let's have a bit of a chat about some of the electronic systems, and again, your background, electronics engineering. There, we've got somewhat of a crossover between the motorsport industry with the wiring and electronics in that, particularly wiring harness development as well. So you got some pretty nasty challenges with yachting, particularly involving water, and not just water, it's also salt water. How much of a problem is that to deal with your design and development of the electronics package?
There are definitely key struggle points that I'm sure everyone came across where, well, the nice thing with this class is compared to the old class, the catamarans was most of it's inside, and unless you sink, that happens. It's like an IP54 box, so most things inside are dry unless you have a shocker. So that means it's not so bad.
Do you know off the top of your head what the 54 ingress protection standard actually means? I don't know them too well. How waterproof is IP50? Did you say 54?
54 would be like rain.
Yeah, okay.
Maybe from the sky.
Yeah, so not submersion.
Certainly not submersion.
Yeah, okay, cool.
and probably give it the 54, because actually with a carbon fibre boat, there's going to be a lot of dust in there.
Yeah. Okay.
So on the so inside's normally fine. I think everyone had trouble with the fact you're trying to put sensors and control systems in the wings, which were in the water, and not just in the water, but in the water at 50 knots.
And there's movement between that and the hull as well.
Yeah.
Right.
Yeah, on an articulating part. So I'm sure everyone struggled with that. And I'm sure everyone had a good way around that. And then the hulls, same again. When you're outside in the cockpits, they got really wet, submerged. And I think the key was being inventive, how you do your waterproofing.
Sure. Are you relying on some of the sort of industry standard motorsport connectors like Autosport, for example, or are you using something completely unrelated to our industry?
A bit of both. Certainly, it's hard to get away from some of the good Autosport connectors like ASC, the ASC range. We use those. I'm sure everyone uses those. Plastic connector, doesn't corrode.
Mm-hmm.
They fit together, relatively waterproof. But there's probably limitations, like a DT connector, you might say, in Autosport. Yeah, that's waterproof, even waterproof from the back. But once you start using it in a marine environment, you're like, that's not waterproof from the back and not really from the front either.
Yeah.
So you're going to get inventive if you're going to use that kind of connector.
Yeah, sure.
So inside's fine, high up's fine, outside, no, you were not going to use that. So
it's a case of really choosing your connection option for the application.
Choosing a connector option, and there's always questions you got to raise. Like every time you make a new part or you design the cockpits, do we need a connection there?
Mm-hmm.
Like, is that connection actually helping us make another sub-assembly? Are we ever actually going to change that? No. Okay, well, let's just not do a connection.
Yeah, I mean, we talk a lot in the motorsport world about connections and the best options. The age-old debate's always solder versus crimping, and I mean the reality is, I think we've done it to death. Crimping is always seen as more reliable, which is why we see it in the motorsport industry. But what beats a crimp is no connection at all. So yeah, if you don't need a connection, then that's obviously going to give us no potential reliability problems, which is the ultimate.
Yeah, and I can see. It must be an interesting question in the autosport world. Like we say, you've got 2 races a day. If you have a failure on a bit of hardware outside, or a bit of hardware anyway, you've got to replace it. Is there any danger you're going to replace that between races? If the answer is no, why have a connector?
Sure.
So where possible, don't have any connectors. And if you need to, try and mitigate the danger there. So I think maybe compared to the other teams, we'd be a team that has just generally less connections throughout, and wherever we can, just don't have it if possible.
I can also only imagine that you've got a pretty diverse range of voltages and currents for the different systems. I assume you've got some sensor-based packages, which might be, I'm only guessing here, maybe working on sort of 12, 14 volts like automotive, but I'm guessing some of your hydraulic actuators are maybe a little bit higher voltage in current draw. Is that correct, or am I off the mark?
Yeah, I don't know what I can say about this, but essentially a big range. There's a maximum allowed voltage. I don't know what that is, but I presume it's somewhere around the 60 volts area.
Sure.
Off the top of my head, and there's also has to be DC.
Mm-hmm.
And within that, different autos. A nice thing we've definitely encountered is a lot of sensors or autosport sensors. So you're probably going to need somewhere, but you need 5 volts at the bottom end, but so many things now are so diverse that you might be looking to a 9 to 36.
Yeah, okay.
And sometimes you got to kind of get it in that range, and a lot of the actuators might be 48 volts. And there's a lot of playing around. It makes it quite fun to design your system, and my head of department is definitely an expert in this, where you look at the schematic and you think, what's going on here? And you've got like this voltage going there, I might stop, and then another voltage is going to go past it to something else. or that'll do a drop down here, or no, we can go straight with that there. So it makes your actual design of your system complex.
Yeah.
And then splitting into 3 systems as well. So there's a lot on with voltages. You're right, yes, and current.
What about when it comes to communications between different devices? Are you guys using anything like a CAN bus or anything like that for communicating between systems?
Yes. Well, between the systems, we've separate systems, but between the hardware, yeah, we use a CAN bus and another type of bus. We have a bus system for communication, yeah.
Right.
In the old days, in San Francisco, there was a rule which was 1 button, 1 actuation. So people ended up with just heaps of cables, like this button's going to that hull to activate that. But now, yeah, you kind of ECU stuff and
Simplifies
bus networks
things
running
and
around the place.
makes things more reliable.
Yeah.
That rule you're talking about with 1 button, 1 output, this is just around trying to stop people doing clever things with automatic control systems.
Yeah, yeah.
Right, so it's easy to check, easy to scrutineer kind of thing.
Yeah.
Right.
And that's not how it is anymore.
Yeah.
But,
So in terms of that, so obviously there's some pretty smart people involved at the pointy end of every America's Cup team. So that obviously opens the door for potential, should we call them loopholes, or maybe just outright cheating. What's the sort of scrutineering strategy, particularly around the electronic control systems? I mean, do you have to supply, if you've got bespoke systems, do you have to supply the raw code so they can look through that? Or, yeah, have you got mandated logging systems for the scrutineering alone?
There's no external logging system within this class. I have been with another class where there was an external logging system, but everyone's under the rules committee, and they've got inspectors, and I'm sure, just like every sport, it can be a bit of a pain when they come round, but we had to provide any custom hardware we made, we had to provide a sample, we had to go through, because the key is that you are not allowed to have instrumentation data going to your ride height control, essentially, to close that loop.
Yeah.
So most of the inspection was towards making sure that something on one system wouldn't have a Wi-Fi chip in it that would connect to another system,
right,
that you wouldn't be able to see, because they'll go through the whole boat and they'll just check every cable doesn't actually connect up this system and this system.
Make sure they're completely separate.
Yeah, the scrutineering is mostly about either not having instrumentation on the ride height system, like sticking your IMU on that system, or it will be not having communication from one to the other, which would be a Wi-Fi or a Bluetooth setup. And they so as it got more to the pointy end, we had to get everything stickered off. If we had made something, they'd inspect it, sticker it. I get the impression this might happen in motorsport, where you get things tagged, you're not allowed to open.
They seal it up.
Seal it up.
It's pretty common.
Yeah. Seal it up. Seal it in place as well. That's another thing they did. And then the end of that road was they would interview people, do an affidavit, you'd sign. I haven't cheated.
So the honesty system.
I mean, it sounds ridiculous, but it's not that big an industry, and if you wouldn't want to come out, and it would be difficult if you were found to be cheating and you were known for it.
Yeah, totally.
I don't know if you get more job offers or less, but
maybe. There's plenty of that's gone on over the years in motorsport in just about every different class.
Yeah.
Just coming back to the electronics and reliability, obviously anyone who watched the America's Cup this year, there was a bit of a disaster with the USA boat, and it just about sunk, which was a bit of a disaster. Obviously, no one wants to see that, even if they're a competitor. And that sounded from the outside, we only saw the media sort of reports, but sounded from the outside like it was a real group effort with all of the teams chipping in to get them back on the water. Can you give us a bit of an inside view on like what actually was damaged on that boat? We saw a massive big square hull in the carbon fiber hull, which is never good.
Yeah.
And how much had to get rebuilt and replaced?
Well, I think the easy part was the physical bit, was that the hole, sorry. They use some of our they use our build facility to make this big panel, which was absolutely massive to do the fitting in there. But I think the hardship was the electronics. I mean, the hydraulics, it was built to keep 300 bar on the inside of it, so no water got in there.
Yeah.
But then I think all the electronics pretty much were damaged. I don't know what they were using, even though I asked them. So I don't know what they were using, but I heard that they had to remove all of their wiring from the inside of the boat. And on the instrumentation side, because they were under the time pressure, they just tested it and they're like, okay, instrumentation side, this looks pretty good, but if we lose a bit from it, we'll probably survive.
Yeah.
But they redid all the wiring on their control side. And I think that was a huge job. Put them under massive pressure.
Can only imagine.
And not only, our response to it was, if this happened to us, well, could we do it? Yes. But the problem will be, I don't think anyone would carry the spare parts to rewire a whole boat. So then you've got to think, we actually need to stock all this stuff because a catastrophic failure
can happen. That was going to be my next question. In motorsport, it's pretty common at that top end for teams to have a complete replacement electronics package, spare harnesses, the works. So not common in America's Cup.
I thought it would be. Certainly in Bermuda with Japan, we didn't, but Oracle would have. They'd have had a whole set of everything. I
mean,
think
a lot of this must come down to budget.
Budget, yeah. For us, budget.
I mean, this is like when you talk about the wiring harness for a boat, maybe it might seem simple at first thought, but I presume this has been an enormous, complicated harness we're talking about here. So
I guess the other thing that's easy to overlook is a lot longer than in a car.
Also a lot longer.
Yeah. I think the two things you'd have would be, it's a massive harness. The boat's 70 foot. And this thing, you're going to have 3, and it's not going to be end to end. Yeah, it's just massive. It would be super expensive. I think, I can't remember, I got a rough price for the one from the Americans, just for one of the 3 looms, and it was in the 150 grand area, but I actually don't know if that's US or Kiwi. Either one's a lot of money, but one's a lot of money. And then all the hardware, probably they had the parts, I don't know, but once you've got past the price, also there's a thing that we, until rarely at the end, would change something almost every day. We want to try measuring that, or we want to try moving this. So you're always changing around, and it's very hard in that situation to lock down, to have a spare, because you're always changing.
There's always iterations.
And I imagine, your car system, you might change year on year, but you probably don't change day to day.
Maybe not quite year on year, but generally not day to day. Once it's done, it's done. Yeah. Plus, an autosport harness is pretty hard to make changes to realistically.
Yeah. So I think you just no one ever thought you would have a catastrophic situation like this that would be so catastrophic. We capsized all of our boats, it seemed like all the time, and generally it wasn't such a major, but no one ever thought you're going to sink one of them.
No, you just never quite know what's around the corner.
Yeah.
I mean, hopefully that is a rarity and we don't see that.
Yeah.
All right, so let's move towards the future. Obviously, we've got a bit of time now between here and the next America's Cup. What we've seen as well is some pretty dramatic rule changes, and obviously as America's Cup has become more expensive, so a few of the competitors may be fallen by the wayside. So is there a drive to bring the cost down for the next America's Cup to get more countries involved, more syndicates involved?
I think there always is a drive to do that, but whether it ever ends up cheaper, I don't know. There was, although I'm not in the inside loop of this, I'd imagine for the next one we might see more one design parts. There might also be an update of the old one design parts, because we went through 3 years with one system and found trouble with it through that time. So there might be an update of that. Be more one design parts. There might be limits to sailing days or times or periods, which will all be with the aim of cost cutting. And also next time, I imagine all the teams will sell their boat ones, or maybe even their boat twos, because everyone will build another boat at least. Or there may be a rule that you can only build one boat.
Yeah.
Which all notionally would save money, but
I think when you get to any form of competition at that level, people still find less and less important ways to spend the budget that they've got, or maybe they don't have anyway.
Yeah.
It's cost savings. The idea is always admirable, but the reality often doesn't work out quite that way.
Yeah, you can't point the finger at Team New Zealand for making it expensive, because we had the lowest budget of anyone. Maybe by less than half of some of the teams.
Sure.
If they want to save money, it's a good idea. But I don't know how it will come about, and it'll still be expensive. But maybe what a Kiwi expensive is different from an English expensive, or definitely different from an American expensive.
It's all relative to your sort of your basis, I suppose.
Yeah. To some extent, whoever, I'm probably simplifying here, but whoever wins the cup has a large influence on the next rules cycle and what happens next. Is that right?
Yeah. In Notion, they've got total control of what happens next, but in reality, whoever wins it and then whoever challenges it, this is a complicated system, but you end up with whoever owns the cup plus one more who is the
challenger of record.
Yeah. And they decide it. And that's what's going on now. That's why we've got such a big gap between one and the next. But I don't know, but as far as I know, it'll look quite similar, because the cost of designing another one from the ground up is massive.
Yeah, it makes sense. Stick with something iterative development rather than a fresh sheet of paper. Design's got to be a more cost-effective option, I think. I mean, the spectacle, it's I can argue it either way. The spectacle of these foiling monohulls is just crazy. I'd personally love to see them in person rather than on the TV, but the argument as well is it sort of takes away from the purity of what sailing was supposed to be. I don't know if there's any winners in that argument, though. I'm all about speed, so for me, the foiling, bring it on.
Well, I had a bit of spare time when the racing was on. I went back and watched some of the old races, like 2003, on YouTube. Like, how long is this? 2 hours.
Yeah,
Oh, God. I don't have 2 hours to watch the whole race. Just skipping through it, like, it's still going? We're not even halfway.
Yeah.
What's your perspective on that? You're obviously a pretty accomplished sailor in your own right. If it was up to you, would you be going down this, expensive and impressive foiling path, or would you like to see it more of an old school hull in the water situation?
Certainly, from a professional standpoint, this is the way forward. I couldn't imagine now if they came back and said, "Okay, we're going to go back, put the boats in the water." No foils, one mast, sails, and like old school winches. Then we'd all be hanging around like the old days in 2007. We're like, okay, what are we going to do today? Oh, we're going to try and find a compass that measures heading to like 0.0001 degrees. Great. Well, that's going to be the job for the day. It's not the same as now. You're like, oh, we're going to try this stuff and it's a lot more exciting rather than before in the electronics world. You change the batteries, you wipe things down, and that. So from a professional standpoint, definitely stick with this.
Cool.
Yeah,
I think we'll start wrapping things up. It's been really interesting so far. I mean, for you, obviously the next America's Cup is a ways off in the distance. So what's next for you for the time being? Will you still be involved in the next defence?
I hope so. Yeah, Quite a lot of us have got the nod that they'd like us to be back with Team New Zealand. I want to go back to Team New Zealand when it happens again. I'm in a bit of a situ now, waiting for another visa, so I'm just enjoying my time in New Zealand. Might head back to Europe when civilization returns.
Sure.
But I don't know.
Worst places in the world to be stuck.
Yeah, I would say for the last 2 years.
Yeah.
Yeah.
One of the things we like to ask people on this podcast is for maybe anyone who's up and coming and interested in following somewhat of a similar career path to who we've got in the show, is if you've got any advice or guidance you'd give to a younger version of yourself, if you want to think of it like that.
Do engineering at university.
Not international relations.
Not IR, no. And then if you want to get involved with the America's Cup in particular, then the best way to do it is to ask. I think there's an outside view that's very hard to get in, but if you're in the electronics world, if you're pretty solid at doing a bit of your wiring, your electronics, anything that you would learn from here, actually, you could apply, you could ask, and there's a good chance someone will give you a go. As long as you're willing to work like 70 or 80 hours a week and like for 3 years, and you've got the right ethic and you're solid at what you do, there's a good chance
it's super
you'll
appealing.
get a shot.
Maybe I'll look at a career change.
Yeah, so I would say ask. Is a big misconception that it's hard to get into. If you're good and you've got a right attitude, you've got a good chance of
They're always looking
turning
for
up.
quality people.
Yeah.
That's what you're saying.
Yeah.
Great.
Yeah, so if people want to follow you personally or Emirates Team New Zealand, I don't know, you got some social media accounts you can chuck in there?
Certainly I don't, but
Perfect.
I imagine Emirates Team New Zealand must be pretty easy to find.
I can't imagine it being too difficult. Yeah. Search for it.
Yeah.
All right. Look, really appreciate your time there, Pete. Been really interesting getting some insight from your perspective there, and appreciate you coming on the show.
Yeah,
Thank
thanks
you.
very much, mate.
All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.